Okay, so the quiz question was b to the fifth over 2 all to the negative 2 power. Okay, what's the rule with powers outside parentheses? Powers outside parentheses multiply powers inside parentheses, right? So now, what are the powers outside the parentheses? I mean, inside the parentheses. There's the 5, and then there's also a 1 power on that 2, huh? Right? The invisible 1 power that's always on anything that doesn't have another power. So that minus 2 goes boom, boom, hits both those. You get b to the minus 10 over 2 to the minus 2. Good so far. And then negative powers are unhappy. They're going to jump. So then you get 2 squared over b to the 10th. Like that, the powers become positive after they jump, don't they? So there's the answer. That wasn't there, so it's none of the above. Huh? Good? We all happy about that? All right. Well, so let's dive in to question number 2. I'm in section 4.5. I'm going to make that a little bigger for you. 9x to the 5th times 4x to the 4th. If you had questions on your exam, grab me at the break. I'd be glad to answer any individual questions you had on why certain answers weren't different or something. All right, so remember multiplying letter type things? How do we do it? What's the rule when you multiply number letter situations? Do you know this already? Let me help. Out front numbers multiply. So the out front numbers multiply. And what do the powers do? I bet you know. What are the powers going to do? What's the little 5 and the little 4 going to do? They're going to add, huh? Out front numbers multiply, powers add. So 9 times 4 is 36, and the powers are going to add to be 9. Like that. And there we go. So out front numbers multiply, powers add. Any questions on that one? Remember those rules? Have we seen that before in here? I can't remember. I forget where we have or not. All right, so out front numbers multiply, powers add. Okay, so we have minus 3x, and we have x minus 8. So that minus 3x in the front is going to multiply both of those items on the inside, right? It's going to distribute, we call it, right? Like when I distribute an exam and I pass one out to everybody, that minus 3x is going to distribute himself. He's going to pass himself out to everybody. And every time he multiplies, what's going to happen? Out front numbers multiply, powers add. So here we go. What are the powers? Invisible 1, huh? So what happens with minus 3x times the regular x first off? Minus 3x squared. Good so far. Plus, then minus 3x times minus 8, and 8 times negative? Positive 24x. Good like that, and we're done. That's all we need to do on that one. Any questions? All is well. (5x) 3x squared minus 5x plus 7. So try that one. So take that 5x in the front and multiply the other 3. Boom, boom, boom. So 5x times 3x squared. Yeah, because the 1 power adds. So 3 times 5 is 15. X cubed. Good so far. Good for that first one. Front times front, right? Out front numbers multiply, powers add. And then 5x goes to the second one. Minus 25x squared. Again, the 1 powers add. Plus 5 times 7, 35x. There we go. There's our answer. Is that okay? Questions on that? All right, stop me if you want to talk about it. Otherwise, I'll just... So we've got x plus 8 times x minus 6. So what's going to happen here? We're going to FOIL this. Have you seen this before? You have two terms multiplied in two terms. And so what might help? Let me move the signs first off. You know, the signs are going to go with the thing they're right in front of. So I'm going to just put them right on them just so we know there's no mistake. So that plus sign is right on the 8, that minus sign is right on the 6, right? Pluses and minuses, they go with whoever they're in front of. Because now everything's going to separate, right? Okay, so here we go. How's this going to work? First off, the x is going to distribute himself to both of the other two. And then when he's done, it'll be the plus 8's going to have his turn. Does that make sense? They take turns distributing. So first, the x is going to go to both the 2 in the other parenthesis, and then the plus 8 is going to go with both the 2 in the other parenthesis. So it's double distribution, if you will. So x times x is x squared. X times minus 6 is minus 6x, and he's done. So far, so good. So that x went to both. First to both. All right, now that he's done, now the plus 8 is going to go to both. Plus 8x, and 6 times 8 is 48. Negative, right? Because positive times negative. It's negative 48. We good to there? These two make plus 2x. Oops, there goes my video. All right. And we're done. Now, everybody okay with that last step where those middle two combined as like terms? Does that make sense? 8x minus 6x makes that plus 2x in the middle. And there's our answer. So notice the first we're multiplying on the first line, and then we're adding, subtracting on the second line because there's no more parentheses, right? So we're just adding, subtracting the middle two. Questions on that? Is that okay? All right, I'll keep moving. Okay, so let's try, here's my video again, huh? 4x plus 7 times 4x plus 7. So try that one. So it's double distribution. The 4x goes first. He goes to both the other two. And then the 7 goes to both the other two. So the 4x will go boom, boom, to both those two. So as it does, out front numbers multiply, powers add, right? Bless you. 4 times 4 is 16. X1 is x squared. And then 4x times 7 is 28x, done. 4x's turn is over. He went to both the other two. Good so far? And now, the 7 is going to go to both. Plus 28x plus 49. That good to that point? First to both. Some people call this FOIL, by the way, which is fine with me. If some people, they like to think of it as FOIL. That's another way to do it, which will work fine. Remember, do you guys know what FOIL stands for? First. Yeah, outer, inner, last. Right. So that's just a nice way to remember it. It means the first one in this parenthesis times the first one in that parenthesis. That's exactly what we did. And outer means the two outer. That's exactly what we did. The two inner. That's exactly what we did. And the last times the last. That's exactly what we did. So either way, you'll get the same exact results. Whether you go first to both, second to both, or FOIL, FOIL, first, outer, inner, last. Either way, you'll get the same thing. Now, we're not done, huh? One more step, right? The multiplying is over. The parentheses are gone. Now we're just adding subtracting mode, right? The multiplying was step 1. So now we can add these two in the middle, can't we? So add those two, you get 56x. And there we go. Is that good then? Questions on that? All is well? All right. So use your calculator. All right, try that one. So this x will go to both. Get x squared plus 4.2x. He's done. And then the minus 3.8 will go to both. And then somebody have a, what is 3.8 times 4.2? Like 15 or 1596? Thank you. Is that okay? Y'all getting that so far? First to both, second to both, or FOIL? Now what? Well, now these middle two are like terms. Those two in the middle can add, subtract to be like terms. So what do we have? 4.2 minus 3.8, what's that? 0.4x? There we go. Questions I can answer. No questions, no problems? All is well? Yeah, afterwards, exactly. Yeah, so the first step's the multiplying, and then here we do the like terms. You're totally right. It's the second thing. Yep. All right. Keep. They're just trying to picture for us this multiplying. Let me draw it over here and make it a little bigger. So they're saying this is B, and they mean that height is B, and 2, they mean this height is 2, and 3 is that width, and B is that width here. Get a little better. Okay. So there we go. So there's the picture they're giving me. And they want me to figure out the total area for the figure. Well, how do you do that? I mean, what's the area of a rectangle? It's a rectangle, right? So what's the area? It's a big old rectangle. So what's the area? How do you find the area, area of a rectangle? Like if you wanted to go buy new tile for this floor in here, this room's a big rectangle, right? How would they know how much tile to get? How many actual square feet? This is a square foot, right? About a foot by foot square. You buy tile or carpeting or any kind of flooring in square feet. Like how many square feet for this room? How would they figure that out? Yeah, just one side times the other, right? Base times height, length times width, whatever you want to call them, totally right? You would just measure that wall and then measure that wall, or you could do those two or those two, whatever. Just measure two sides, multiply them, you get all the area in between. Right? You know about that formula? I don't want that to be something Mr. Heron says, but something that really makes sense for you. Right? Let me just do it real simple like this. Right? What if I said, hey, I've got 4 squares tall and 3 squares wide. How many total squares do I have in the shape? Yeah, you can see there's 12 squares, huh? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We call those square feet, for example, right? Actual squares, foot by foot squares. Right? If it's 3 feet wide, 4 feet deep, you know that's 4 rows of 3 or 3 columns of 4, however you want to say it. One side times, yeah, this, you can multiply this side's 4, this side's 3. You can multiply, this 4 with that 3. It doesn't matter. One side times the other, 12, huh? There's 12 actual squares, area in the middle. Make sense? So, with that in mind, how are we going to figure out the area of this overall shape? That's what they're asking us for. So, yeah. How tall is this whole side? 2 plus b. Or b, how about I put the b in the front? But you're taller. b plus 2, 2 plus b, either way, same thing. Very good. And how wide is it? b plus 3. Everybody see that, right? The total width is 3 plus b, or b plus 3, same thing. Right? And the total height is 2 plus b, or b plus 2, same thing. Does that make sense? And then for area, you're just going to multiply one side times the other side. So it doesn't matter what order. I'll put the b plus 2 first, but you can put the b plus 3. Doesn't matter. Just multiply one side times the other side to find the area of any rectangle. Is that making sense? Is that good? And then just carry that out. Can you guys foil that out? So go ahead and foil that out as we've been practicing. So here we go. What do you get? B squared plus 3b. And then the 2 goes to both. Plus 2b plus 6. And that's what? B squared plus 5b plus 6. Done. And there goes the video too. The video's done. It's all done. Let's see if that helps a little bit. Maybe it wasn't connected well. I don't know. All right. Is that good? Does that make sense on that, foiling that out? So that's the answer they want. Now let me show you why they're doing the picture thing. You don't really have to do anything with the picture thing. I mean, you can just say, look, it's b plus 2 times b plus 3, and just foil it, and you're done. But the picture also, if you're interested, could show you a little bit of why. What if, think with me guys for a second, what if I wanted to find the area of just that part? Just that section. How would I find the area of just that section I just colored in green there? What's that section? Well, it's a little rectangle, isn't it? In any rectangle, big or little, just go one side times the other. So one side of this rectangle is 2, the little green rectangle. The other side is 3. So the area of this little piece is just going to be 2 times 3, or 6, huh? Just that part. See the 6 right here? Okay, now what's the area of, let's say, this up here? Yeah, do you see it? It's just one side times the other, right? how tall is this side? Well, B. And then how wide's this side? Or you could do the top, whatever. It's 3. See it down there? Right, the width is 3. Put it there, whatever, it's 3. It's B times 3. B times 3, or 3B, which is right there. See how those 4 pieces are going to be these 4 pieces? They're just showing you pictorially what FOIL really does. Okay, what's the area of this part right here? Well, what are the 2 sides, right? Any rectangle, one side times the other. What are the 2 sides? Can you tell by the picture? Like, what's the height there? How far from there to there? B, because it's over here, right? And how wide from there to there? Well, it's right there, yeah, B. It's B times B. It's B squared. Can you read that? Okay, yeah, B squared. So there's the B squared. Finally, last part of the puzzle is this down here. What's the area of that shape? 2 sides. What are the sides? One of them is B. What's this? How tall is this? How tall from there to there? 2. It's over here, huh? So it's 2 times B, or 2B. 2B. You see those 4 parts? Those 4 different sections are the 4 parts of a foil. So they're just showing you that you don't have to do that every time. That'd be crazy. It'd be too long. But they just want to show you, hey, you know, that's what we're doing here, really. Because we're just taking the parts of a rectangle and we're adding them up with the foil. That's really what's happening behind the scenes. All right, so they want you to fill in the boxes that are missing. You know what I mean by that? Do you know what they mean by that? They mean like, what goes right here? What goes right here and what goes right there? That's what they mean. Those 3 empty boxes. Can you figure out what goes there? It's just the side-by-side thing again. You know, it's the rectangle. 2 sides of a rectangle multiply. So, in other words, what must go right here? What is this side? And the top is X. You can see on the picture right here. The top is X. What's the side so that they multiply to equal 3X? The area of that upper left-hand corner section up here is 3X, right? That's the answer they're putting inside 3X. So they got that from one side times the other side. Well, we know one of the sides is X. So what's this side got to be? It's got to be 3, doesn't it? This side must be a plain old 3, because then 3 times X is 3X, isn't it? See how we figured out that box? Because the 2 sides multiply to be the space in the middle for a rectangle. Okay. So, this is 3. Kind of erase all my scribbling. This is 3, and it's the height from there to there. So then what goes in this box here?
21.
Good. See, everybody seeing that? Because from here to here is 7. Remember, for a rectangle, it's one side times the other side. This is 7. This is 3. 3 times 7 equals 21. Good? And then finally, how about here? What goes in this box? Good. Right? Everybody seeing that? Because one side times the other side, this side's 7, this side's X, 7X. Right? This side's X over here. 7X. That's all they want. Just want to make sure you understand the different pieces. Questions on that? Make it ugly, unfortunately, at this point. So now I'm going to put the smaller one in the front. I think it's easier. Put the smaller parenthesis in the front. You don't have to, but I think it's easier. So x minus 8 in the front and x squared plus x plus 8 in the back. Put the little one in the front, the big one at the back. So we're multiplying the little parenthesis times the big. So it's just a lot of work. Can you crank through that? So that x will go to all 3, and when he's done, the minus 8 will go to all 3. 6 multiplications all together. H2, okay. Make sure that, that minus sign is right on that 8. So the x goes to all 3, and we get x cubed. Remember, powers add. X cubed plus x squared plus 8x. He's done. And then the minus 8 goes to all 3. Minus 8x squared minus 8x minus 64. Good so far. You know what it might help is to line them up vertically. You don't have to at all, but I've found some students like it better, a little easier to see things. So I'm going to put the minus, put the x squareds on top of x squareds, the regular x on top of regular x, and just makes it a little easier sometimes. So minus 8x and then minus 64. So I just lined up x squareds on top of x squareds, regular x on top of regular x. You don't have to, but some people find it easier to see what's going on. So then you can just, now we're in the last step, you add and subtract numbers in the front only. Don't mess with powers, right? So it's just x cubed. And then right here, these two, what do they make? What is plus x squared minus 8x squared? Yeah, because it's plus 1 minus 8 is minus 7x squared. And then these 8x and minus 8x cancel. Minus 64. There we go. Is that good? Anything I can answer? Okay. So y squared minus 3, 3y squared minus 4y plus 8. So watch your signs carefully. So here we go. So out front numbers multiply, powers add, right? So y squared times 3y squared is 3y to the 4th. Y squared times minus 4y is minus 4y to the 3rd. Y squared times 8 is 8y squared. And he's done. Now the minus 3 goes to all 3. Minus 9y squared plus 12y minus 24. Everybody get those signs right? That good? To there. So first to all 3, second to all 3. And then just gather the like terms. So 3y to the 4th. Minus 4y to the 3rd, plus 8 minus 9 is minus 1y squared, or just minus y squared, plus 12y minus 24. There we go. Are we good with that? Are there questions I can answer? No problems? All good? All right. And then we're about done with this section. So I'm going to make these x's because my t's look like plus signs. So minus 4x squared minus x minus 8, the first parenthesis. Second parenthesis, 6x squared plus 4x minus 1. Shall we try that? So how many multiplications altogether on that thing? How many? A lot. First to all three, second to all three, third to all three. How many? 9 multiplications, right? 3, 3, and 3. Right, you know what I mean? So first off, that 4x squared is going to go boom, boom, boom. He'll visit all, the 4x squared will visit the other 3. When he's done, the minus x will go. When he's done, the minus 8 will go. They take turns visiting the 3 in the other parenthesis. Out front numbers multiply, powers add. Now, it might be nice to line things up vertically. I'm probably going to do that. I'm probably going to put x cubes over x cubes and x squareds over x squareds and try to keep it all lined up. Good so far? Making sense? And then the minus 8 goes to all 3. Good, and then we go vertical, right? So 24x to the 4th. Good, it's making sense. I'm racing ahead of you. So I'm adding, subtracting. So I did the 9 multiplications, and now I'm just combining like terms. I stacked them vertical to help. So what do those ones make? Minus, is it 56? X squared, I think, right? Yeah, 56. And then these two make plus 1 minus 32 is minus 31x. And then bring down the 8. There we go. There we go. Questions on that one? Is that good? It's close to as ugly as they get right there. Maybe with fractions it's even a little worse. If you do that, you're doing well. No questions? Good? I'll move on. Okay, so let's do this. This is a bad one. So x minus a half. Get a little bigger. X minus a half times 4x cubed minus 6x squared plus 3x minus 2/5. All right, try that one. So that first x goes to all four. Good. That x goes to all four. And so what do we get? 4x, powers that, right? 4x to the fourth minus 6x to the third plus 3x squared minus 2/5 x. He's done. So far, so good? So that x goes to all four. Next, the minus a half will go to all four. And I'm going to line them up vertically. So what's half of 4? 2. So it'll be minus 2 x cubed. You okay? So if it's even numbers, you can just take half of them straight, right? Half of 4 is 2. Half of 6 is 3, right? Minus 3x squared. So I just took half of 4, half of 6. Oh, it should be plus, shouldn't it? Because negative times negative, we got a negative on the half, we got a negative on the 6. Two negatives make positive. Watch out for your signs. Now, what about when you go the minus a half x times the 3x? Let me write it over here. Or minus a half, I mean, times the 3x. You can't take half of 3. I mean, you get a decimal, 1.5. We don't want to do decimals. So how do you do half of 3? Well, you just make it 3 halves, don't you? Because the 3 is over 1, goes to the top. Remember, whole numbers are over 1, they go to the top. Remember that? Something important to know. Whenever a whole number is interacting with a fraction, it's over 1. Goes to the top. Finally, what about minus a half times minus 2/5? Minus a half times minus 2/5. 2's cross cancel, don't they? Remember that? And it's plus, because 2 negatives make positive, 1/5. And there we go. Questions on that fraction one? Is that okay? Oh wait, I didn't finish. What am I doing? He's got to stop me. Say, what are you doing, Mr. You're not done. I'm just wanting to be done, but I'm not done. Let's keep going. Now we got to do them vertically, don't we? Bring this down. Are we good? Are you guys with me? It's in moments like that that I feel like I'm talking to myself. Like I could do anything up here. That good? Keep going. And these two. Minus 6 minus 2 minus 8x cubed, right? If you lose 6, you lose 2, you lost 8. Why don't 2 negatives make a positive? Why didn't these 2 negatives make a positive here? Yeah, because we're adding and subtracting, we're not multiplying. When you multiply, yeah, 2 negatives make a positive, or divide, 2 negatives make a positive. But if you're adding, subtracting, it just gains and losses. You lose $6, lose $2, you lost $8. So, all right, and then these guys make 6x squared. Okay, now the real trick is those other two, huh? What am I going to do with these guys? What am I going to do with the minus 2/5 x and the minus 3/2 x? How do you add, subtract a couple fractions like that? Common denominator. Unless your calculator will just do it straight. Just do common denominator. So multiply top and bottom of this one by 2. Top and bottom of this one by 5. And so what do you get? Minus 4/10 x minus 15/10 x. And then bring down the 1/5. And then you can combine those two, huh? Can you read that down there? Wait, let me move it over here where there's room. Yeah, let me just move it over here. So it's minus 4/10 x minus 15/10 x. Right there, right? Multiply top and bottom by the other denominator to get common, right? So you got a 1/5 and a 2nd. Multiply top and bottom of the 5 by 2 and the top and bottom of the 2 by 5 to make them both 10. Huh? Common denominator. Then you can combine them minus 19/10 x. Huh? So that's minus 19/10 x, and then you just bring down the 1/5, and you're done. There, we're really done. Is that okay? A little painful on that. That's the hardest one in the section. No questions? All is well? Good? All right.